Hello everyone. In this video, we will try to see about hardware programming in 8051 microcontroller with Keil C51. So today's hardware which we are going to see is on LCD interface. So might have heard about LCD. LCD stands for liquid crystal display. So we will try to understand the basics of LCD and we will try to understand how our kit has been interfaced with this LCD, and we will try to do a small program with our LCD also. So just the basics of your liquid crystal display. A liquid crystal display is an electronically modulated optical device shaped into thin flat panels made of any number of colors, monochrome pixels filled with your liquid crystals. So the main advantage of LCD display better compared to your CRT, it is going to be battery powered. So that modern equipments which is going to consume battery powers, there is no necessity of having higher voltage for its operation. It can be having the display with LCD. So it emerged with an greatest advantage there. So LCDs have become cheap, and we can able to display characters of 16 to 20 characters, and we are having many displays, 2 cross 16, 1 cross 16, all those things in terms of many characters, 4 cross 20 displays. So depending upon your characters, we will try to program your LCD displays. So in our kit, which has been placed, is going to have this 2 cross 16 LCD display. What it means, so here we will be having 16 characters, here we will be having 16 characters. So total 216 characters we can able to display. So it is going to be 16 cross 2 or 2 cross 16, which is going to say that it is having 2 rows and 16 elements inside each row. So this is what it's simplified. We can able to understand from 2 cross 16 display. So in order to make that liquid crystals to glow, we are having an 5 cross 7 display, which is going to be your matrix of lights on the back end of each character. Right? If the character needs to be displayed, so it has to switch that particular character. So if you want to display the letter R, you can able to see here. So it is going to be having 1, 2, 3, 4, 5 here, and here we are going to have 5 cross 7 lights. So if you want to display the character R, it is going to be displayed in this fashion. So correspondingly, we will try to make the displays and we will try to display those characters in the liquid crystals. So this is the back end light, and front panel is going to be your liquid crystal. So dot matrix, which is going to be example, we can able to see it is going to be displaying dot matrix, and it is going to be moving from right hand side to left hand side direction. So we might be seeing many advertisements and many things with respect to LCD displays like this one. So we are going to create such a program in today's lab session. So what are the things we have to understand before getting inside your LCD display? So first we have to understand what is the pins which is available in your LCD display. So in your first slide, we might understand like, yeah, we are having so many pins here, right? So here to here. So what are those pins and how it is being used? So pin 1 is for your ground. So it is for your supply ground, and we are having VCC, which is going to be your plus 5-volt power supply, and VE is for your contrast control. So if you want to control your contrast, we can able to get it with VE. And RS is going to enable your command register. So we are having 2 registers. First one is going to be your command register, and next one is going to be your data register. We are having 2 registers in your LCD display, not in your 8051. It is present inside your LCD display. So which register has to be selected can be determined by your RS, and read bar write is going to select whether it is going to be doing a read operation or write operation. So enable, it is an pin which is going to be very much useful while you are programming your 8051 with your LCD display. So we will understand its importance whenever we are getting very deep inside your 8051 with interfacing with LCD. So this is like the data has been taken and it will be presented to data pins. It is going to be responsible for that one. So we will see that. So after that we are having 8 data pins. So DB0 to DB7, right? So total we are having 8 input output data pins, right? So the pin description. So we are having 8 data pins, which is going to be D0 to D7. It is bidirectional. It can able to get the informations of data as well as it can able to get the informations of command, both the things together. It can alphanumerical characters are sent in terms of ASCII format. So if you want to send the character A, so the character A will not be sent. Instead of that, ASCII values of A will be sent, so that you can able to see that inside your display, right? So we have understood about RS, which is going to be your pin. If it is going to be 0, it is going to be your command word register or your command register. If it is going to be 1, it is your data register. So LCD, so we have to give some commands to this LCD, right? As well as we need to give some data. So whenever you are going to send a command from your 8051 to your LCD, we will be using command register. If you want to send a data to your LCD display, it is going to be your data. So command is like we have seen the dot matrix is going to be displaying from right hand side to left hand side. So if you want to give such things in terms of instructions to your LCD display, that is going to be taken care by your command register. So what is getting displayed? It is going to be displaying like dot matrix, right? So all the characters of which is going to be displayed is going to be given in terms of data register. So whenever command is going to be given, it is going to be taken from command register. Whenever you are going to give the data, it is going to be taken care by your data register. Read bar write, we have already seen many things with respect to read bar write, whether it is going to read or write a data. Enable, so it is a latch data used to latch the data present on data pins. A high to low edge is needed to latch the data, which means, so you are having a data, and if you want to put that data inside your command register, or you need to put the data inside your data register, right? So it is going to take the data on your data pin, and after that it is going to present it to your LCD screen, right? So for this one, a high to low edge is needed. High to low edge, which means, so already it is high, some pulse is high, so whenever it is getting low, right? So whenever you are going to make it from 1 to 0 transition, this event will happen. So whatever you are going to give in terms of data will be reaching your command register or it will be reaching your data register. So a high to low is needed. So we will try to understand more when you are getting into programming also. So just try to understand, enable is going to take the data and give it to your LCD screen. So a high to low is needed for sending the data inside your command register or data register. And after that, VEE is going to be your contrast control for your pins. So for your LCD screen. So while you are using your kits, it may not be available in your kit sometimes. Sometimes it will be available when you are going to interface with 8051. So after that one, so this is the kit which you have already seen. So we are already having an LCD screen. So here we are having 16 characters. Here we can able to have 16 characters. Two rows can be done. So it is going to be 16 cross 2 or 2 cross 16. We have already seen, right? So 2 cross 16 display we can able to have. So this is done, but in which port it has been connected, all those things we have to understood so that we can able to program that specific port, right? So in order to do that, we are going to configure that port as input port or output port in which way we want to get in terms of display. So how your kit is getting connected with LCD, we have to understand that, right? So while you are seeing in terms of VDD ground, all other things is for 8051. We have seen much more detail when you are seeing in terms of 8051. So the port 2 of your 8051 is getting connected to your data pins of your LCD. Right? Sometimes it will be denoted as DB, sometimes it will be denoted as D alone. So this is getting directly connected to your data pins. So port 2 is having your data. So in port 3, fifth pin is going to be enabled. So it is going to give the data to your LCD screen, right? Or it is going to be giving the instructions or the data to your command register or data register. So it is going to be connected to P3.5 and P3.6 is going to be reset or RS. RS is going to determine whether it is going to be your command register or your data register, right? So we have seen that also. So read write, it is going to determine whether it is going to read that operation or read the data or write the data inside your LCD. So these are the things which is going to be used for our programming. So these pins we have to make sure, so that correspondingly we will try to activate those pins to do the job at that specific point of time, right? So these are your LCD command table. So which are the data which we can able to enter into your LCD command register. We have seen command register, right? So this command register, we can able to provide these data so that it will do the specific job inside your LCD. So if you want to give an information like it is having an two lines, so it is going to be 2 cross 16, and after that it is having an each and every liquid crystal. On the back side we are having 5 cross 7 displays, right? So it is having 5 and it is having 7. So if you want to represent on this kind of LCD is getting connected to your display, so that we have to make sure that this has to be given in terms of command word with the value of 38, right? So command 1 is going to clear your display, command 2 is going to be return home, so command 4 shift the cursor to left, and command 5 shift the display to right, and command 6 is going to be shifting your cursor to right, command 7 is for shifting your display to left. So we will see all those things one by one with the help of your programming also. So we will see that. So if you want to display off your cursor as well as your display, both the things if you need to off, you have to give your 8. So if your display off and cursor should be on, it should be having A. Like this we are having so much instructions. So mainly you will be focusing on instructions of 0, 1 and 5, because most of the times we will try to make the display from left hand side to right hand side, right? So after that one we have to switch on your cursor and you have to switch on your display, right? So we will be using 0E and we will be using 0F and conditions. And if you want to in that LCD screen we have seen that 16 by 16 two things are there, 16 characters in here and 2 rows are here. So if you want to select the first row of your LCD screen, we have to use 80, command word of 80. And if you want to choose the second line, we have to give the thing of C0. And if you want to take, so it is having 16 characters, right? So character was 0, 1, 2, 3, 4, something. It is going to be going on. So if it is going to be 80, it is going to be starting its display from its 0th position. If it is going to be 81, it is going to start its display at first position. If it is going to be 82, it is going to be starting its display from its second position. In the same kind, if it is going to be C0, it is going to be starting its display in the second line 0th position. If it is going to be C1, second line first position. If it is going to be C2, it is going to be your second line second position. Like this, we can able to go up to 8F. Here you can able to go up to CF, right? Because it is 16, 2 cross 16, right? So we are having 16 characters can be displayed. So it can able to be starting from 0 and ending with F. So 8 determines it is in first line, C determines it is in second line of display, right? So there is no necessity of mugging up. While we are getting inside, we can able to understand how it is being used. So now our program. Write an 8051 assembly language program to display a message of 8051 on LCD display at first line 5th character position, right? This is our question. So 5th character position. So from the examiner perfect point of view, so he is trying to say 1, 2, 3, 4, 5. So 5th character position, but in terms of our microprocessor terminologies, it is going to start from 0. So actually it is 4th position, right? So since it is starting from 0. So it depends upon how you are going to see that in terms of perspective, in terms of whether it is going to be microprocessor starting from 0 or from the user who don't know anything about our microprocessor, just and display in terms of 5th character. So what are the provided details? We are having to display 8051. So after that we are having the port to access is for 2. So we have already seen LCD is getting connected in terms of data pins with port 2. and control pins with port 3. In port 3, we are having 3.5, 3.6, 3.7 with respect to E, RS and RW, right? So we will see in detail also for that one. So an identical solution, how we can able to end up in terms of solution. So call a time delay before sending the next data or command. What does this means? Because your microprocessor is going to work in a very fast clock. So, but your LCD is maybe having some delay, so that whenever you are going to send a data or a command to your LCD screen, so try to take some time delay, approximately of 20 milliseconds, some approximation of 20 milliseconds. So create the delay so that it will try to take some time and it is going to make its own display, right? So most preferably, so it's not exactly, it should be 20 milliseconds. So you can able to try with some less or high timing also, so that whether it is going to make the display or not, you can able to see that one. So after that one, P 2.0 to 2.7 is going to be connected to T0 to T7. P 3.7 is connected to your RS, 3.6 is connected to R bar W, and 3.5 is connected to enable of your LCD. And your baud rate is 9600 and crystal order frequency is going to be 11.0592. We have seen already many problems with respect to these kinds of baud rate and crystal frequency display in your previous videos itself. So we can able to just quickly move to our programming. So how to program? So we are going to make in terms of origin. So what this implies? So moving the value of 38 means, so it is going to be 2 cross 16 display, and in the 2 cross 16 display we are having 5 cross 7 matrix of lights, right? This is what it implies. So I am just moving your value of 38 immediate addressing mode to your accumulator, and after that I am calling my acall command word. Acall command word, acall is going to be your service routine. So we have seen already acall in terms of our previous programs also. Just go through those videos what your acall will do. Actually it is an service routine, so it is going to jump to that memory location and it will execute the program which is available there, and this specific location is going to be moved inside your stack. So if there is having a memory, so that memory location is going to move to stack, and after completing this execution it is going to jump back to the next position, right? So what I am trying to do in terms of acall, because I have written a subroutine so that the value of 38 can be moved inside your command register, right? So we will see that subroutine we can able to see in our later part of our programming. So this is going to be initializing your display, and this is going to be your calling your command subroutine, which means putting the data inside your command register, right? So after that time we have to create a delay. So again I am going to call an subroutine which is called as delay, which is going to be creating an approximate time duration of delay of 20 millisecond, right? So this is your LCD giving some time for your LCD. So after that one, if you want to display on, and your cursor should be on for making your display, right? So the from the table we have already making note of 0E, right, which means your cursor is on and display is on. So that information has to be moved inside your accumulator. So the value of accumulator has to be moved inside your command word register, command register, right? So after that again I have to create a delay, and I should be making sure, like, so there will not be any previous data available inside my LCD screen, right? So for clearing your LCD we are having 01H. So move to that table. So this table is going to give all the informations, right? 01 is for clearing your data. 05 is going to be a shifting your display to right hand side direction, display on, cursor on, and 80 for your specific lines, right? So after that one, again I have to move that value of accumulator inside your command register. So I will be calling this subroutine, and after that I have to create a delay, so that I will be giving some time for my LCD screen to respond for that one. So after it is going to be 06. 06 I have not specified as 8051, but if the 8051 has to be given the specific way of 8051, so the cursor has to move from left hand side direction to right hand side direction for every character, right? So we have to move the cursor to the right hand side direction, right? For that, I have to give the value of 06 to your accumulator. After that, I have to push that accumulator value inside your command register. After that, I am going to make a delay so that your LCD will respond for some more point of time, right? So after that, I have clearly mentioned in your question. So it is going to be a fifth character position. In that case, it is going to be in terms of microprocessor perspective. It is going to be given with the value of 8. So it is going to be first line. First line, it should be 8 and it should be 4, right? So 8 is going to represent your first line. If it is going to be second line, it should be C4. So this represents your character position and this represents your line. So this is going to be your first line and this is going to be your second line. Right? So here the question is first line. So I should be getting the value of 84. Right? So I will be moving the value of 84 inside your accumulator, and after that I am writing an subroutine so that that value will be reaching inside your command register, and after that I am creating a delay. So now the command register works has been completed. So all these things till now I am giving is going to be instructions for my LCD screen. Now I am going to put the data inside my LCD screen, right? So I have said like it should be 8051, right? So if I am using in double quotation, which means it is going to be considered as your character, and this character is going to have an ASCII value, and this ASCII value will be taken and it is going to be moved inside your LCD screen. And if I am going to display that ASCII value, it is going to display that character only. It is not going to display the ASCII values. So if I am going to give this value with the help of single quotation, it is going to be taking it as an character, and that character will be displayed directly on your LCD screen. So now see here, I am creating one more subroutine so that it is going to push the data inside your data register. Till now it is going to be command register, right? Now it is going to be data register, and after that one I am calling delay, and after that 0 has to be pushed, and after that 5 has to be pushed, and after that 1 has to be pushed. All other things are going to be same. So after pushing all these things, so if I am going to coming out of it, your program is going to end, right? I should not let my program to end. So I am just creating an infinite loop so that your microprocessor will be keep on working till I am pressing my reset button. So it is an infinite loop. Again and again it is going to be jumping in the same location, so that LCD screen will be having its display visible for you. If this command is not there, after execution 8051 will be displayed, and after that everything will be erased. There will be an empty screen. That should not be there. So in order to create that space and time for you to see that, I am creating an infinite loop. So till I am pressing the reset button, this will not be coming out of the loop, so that you will be always seeing 8051 in front of you in your LCD screen. So we will try to understand what is there inside your command word subroutine, delay subroutine, and your data write subroutine, right? So what is command word subroutine, or which I am giving in terms of command? So it is going to be sending your command to your LCD screen, right? So for sending an information to LCD screen, so I have to send that value of accumulator to the port, right? So that the data will be taken by your port, right? So pushing that value of accumulator to your port 2, which means, so the values whichever I am going to give from my 8051 will be reaching your LCD screen with the help of your data pins D0 to T7, since my port 2 is attached to your data pins. So just I am trying to pushing your values, so we can able to see in terms of your screens, right? So I am pushing the value of accumulator 8 bits. So accumulator is having 0 to 7 values, right? So all those 0 to 7 values will be pushed from here to your LCD screen. So it is common for your data write as well as your command write. So I am pushing that value of accumulator. So initially what I have pushed, so I have pushed the value of 38, and after that I have pushed the value of 0E, and after that I have pushed the value of 01, and after that I have pushed the value of 06, right? So if it is going to be 38, so 8421 combination, right? 00 11, 8 is going to be 1000. So it is going to be having 8 bits, right? So these 8 bits will be reaching your data pins of D0 to D7, so that it can be understood, yeah, 38 is coming, but it don't know where to store. But it is going to be reaching your command word, or it is going to be your data word, but it is going to send a data. So data will be remaining there. So after that one, clear P3.7. So P3.7, so while you are seeing in terms of your pin diagram, P3.7 is going to be your read bar write, right? So if that is the case, P3.7, so it is going to be your, sorry, actually I have, okay, so I have interchanged this one. So it is going to be read bar write. So if it is going to be read bar write, so it should be your command word. So whenever it is going to be 0, it is going to be your command register. When this value is 1 here, so we can able to see this P3.7. So sorry for that pin diagram. So it is going to be connected to your RS, right? So I have made a mistake in your pin diagram. So please rectify that. So here it is going to be P3.7. So P3.7, if it is going to be 0 and if it is going to be 1, what will happen? So this is going to be considered as command and this is going to be considered as data. So whatever I am pushing 38 is going to be available in your data pin, right? This is going to be considered as command, right? So the value should be moving to your command register, right? So after that P3.6, it is going to be read bar write. So always the thing is going to be writing something, right? So I am going to write something inside your command register. So it is going to be write. So I am pushing the value. I am writing something inside your command register, right? So I have said that it is command. It is not an data, and I have to write inside your command register. I am not going to take it from my command register. So I have said enable is there, right? Enable is a beautiful thing which is going to be doing. So what is going to be done? So whenever it is having an high to low, whenever I am having this kind of things, it is going to push that value which is going to be present in your data to your corresponding register, right? So I am setting my P3.5 to be 1 so that it is having an first position, and after that a call delay, I am having some delay in that point of time so that it will be having this pulse for waiting for some duration of time, and after that one I am trying to clear my 3.5. So whenever I am going to clear my 3.5, it is having an high to low pulse. So at this point of time I have mentioned it is an command, and after that I have mentioned it is going to be your write operation which is going to happen, and after that I am mentioning like if your thing I am going to push that value inside your data pins to your command register. This will happen if I am going to write like this, right? So it is going to be your high to low. So we have studied while you are seeing your high to low pulse, right? Yeah. So whenever it is going to be high to low, it is going to be pushing that value inside your command register, or it is going to push that value inside your data register. It is going to be your data latch, right? So after this one, we will try to see what is data word. So data register, everything will be same. Nothing is going to be different. Only thing, this P3.7, it will not be clear. Instead, it is going to be set. So that it is saying that instead of writing inside your command register, write inside your data register. All other things are same. Nothing is going to be different from that one. So here, see here, I am trying to create a time delay. We have seen many programs in previous videos how to create this time delay. So this time delay, I am trying to activate your tmod register. Tmod register, if it is going to be getting the value of 01, please go to the previous videos to understand what is timer and how you can able to activate it. So if it is going to be 01, so you are going to work in mode 1 and you are going to activate your timer 0, right? We are having two timers, T0 and T1, and we are having 4 modes. In that you are going to use timer 0, and in mode 1 you are going to operate. Mode 1 is going to say that we are going to start it with FF, and it is going to count till 0000, right? So we have calculated all these things already, right? So if I am going to make such a kind of approach, so whatever we are going to get as an approximation is going to be 17.5 milliseconds. Right? Nearly equal to 20 milliseconds. So if we can able to create 20 milliseconds, that is also fine, but 17.5 milliseconds will do the job of delay for my LCD screen. So I am just fixing with this value. So if you want to create more delays, you just try to create your own delay and you can able to see how much time it is taking for its operation, right? We have seen so many programs with respect to timers. Just try it out and you can able to see how you can able to get those values displayed with a time delay, right? So after this one, we will try to move into real-time kit so that we can able to see how the programming of 8051 on your LCD screen works. So now I have given the program here in your Keil. So you can able to copy the same program and you can able to paste it here. All the instructions are going to be same. So here in kit, we can able to see an LCD is getting interfaced with that kit. So it is having a default characters of ESA MCB 51 something. So it is going to be default version of your kit serial number, which is already programmed in your 8051. So these are going to be your pins of data pin, which is going to be RS, RW, E enable pins, all those things. We have seen about the diagram also, how we can able to make use of that. So it is interfaced already with your 8051 in port 2 and port 3, in which we have already seen these things, right? So correspondingly, we have moved those pins here and it has been already connected. So what we have doing here from here in our program, so we are trying to select your 16 cross 2 display, and after that you are going to say that it is going to be having a display which can be taken in terms of cursor on and display on. 01 clear your LCD screen. 06, so your display is going to be from left hand side to right hand side. 84, it is going to be in your first row, fifth character position, all those things, right? So we can able to run this program and we can able to see how it is going to reflect in terms of your 8051 kit. Yeah. So we can able to see the value of 8051. So here it is going to be 1, 2, 3, 4, fifth character position. So it is starting with 8051, right? So if in case, if you want to make these characters to be in different way, so that I have, we can able to give it in terms of those particular perspectives. So we can able to give a try on those things also. So we have already, I have already created a program for those kinds of things. 06 can be replaced with 04, and in terms like 0E can be replaced with 0F, and these things we can able to see 06, 0F, 84, C4, right? So we can able to see 0F, right? So the same values I can just try to replace with 0F. So I am commenting this line. So what does it mean? 0F mean? So it is going to be your display on cursor blinking, right, in 0F. So if it is going to be cursor blinking, and after that one here instead of 06, so we can able to go to a PPT also and we can able to see instead of 06 what we can able to use. 06 we can able to use it as 05. 05 shift display in terms of right hand side direction, shift cursor in terms of your right hand side direction, shift display on your left hand side direction, all those things we can able to try. So shift cursor to your left hand side position. So this we can able to give a try. So instead of 06 you can able to use 04, and how it is going to make your thing. 04. So I am commenting this line. So instead of 84 I can able to use C4. So for your second line, I am commenting this line and I can able to use my C here, right? So if it is going to be C, we have to add a 0 in front. So these are the things which we are going to make a change. So we are trying to convey an information like it is not an we are going to use your cursor in terms of blinking way, and the display is going to be from left hand side to right hand side direction till now. So here it is going to be right hand side to left hand side direction, and after that it is going to be in your second line, fourth position, which is fifth character position, right? So if that is the case, we can able to save this program, translate it, build, rebuild, get into your debug mode. so that we can able to see those specific things which can be done by this. Yes, see here. So the cursor is blinking, right? We have made that change. So this fifth character position, it is getting 8. So now we are going to move the cursor from right hand side to left hand side direction. So 8 after 0 is will be your next left side position. 5 will be in your next right hand side left hand side position, and 1 will be in your next left hand side position. After that, it is waiting for the next message for its display. So previously it is going to be 8051. Here it is going to be 8051. So all these changes you can able to make. Correspondingly, you can able to use the command register to program your 8051 in the way which we want to make our display. So like this, you can able to make your characters to scroll. You can able to make your characters to run in a particular time delay. So one by one, you can able to give a display as a set of values. We can able to give a display. All those things we can able to try to make those changes and see how your 8051 responds with your LCD screen. Right. So thank you for your patient listening. We can able to see the forthcoming programs with LCD screen in DPTR values while moving into our next video.